Right, students. So as I said, we'll be doing all-in-one conversions, that too cheat sheet for your organic chemistry conversions. Today the topics which I'm going to cover is all these alkanes, alkyl halides, alcohols, aldehydes, acids, amines, benzene, nitrobenzene, aniline, BDC, phenol, potassium dichromate, everything will be there, students. It is a complete 100% conversions of your NCERT, 100%. So I'll be showing you, I'll be providing you the notes here only. See here, 100% conversions, which will include your flowchart, which will include the cheat sheets, okay, or cheat sheets for your organic chemistry. Let us start off with the video, students. Hello students, welcome to one more session of your WOC. Today Vani ma'am is back with a wonderful video, that is the cheat sheet as well as complete mind maps for your organic conversions. So I have prepared everything, students. Only thing you need to do, go through each of them, note it, everything, the complete NCERT is covered in this. Right, students, let us see. So first of all, I have taken this, the first organic flowchart or the conversions flowchart which I made. I have considered all the chapters starting from alkenes, how will you convert it, alkyl halides to alcohols, alcohols to acids. Everywhere above the arrow I have written what is the type of mechanism. In here, what should you add to convert alkyl halide to alcohol. You know, no, aqueous KOH we added for hydrolysis, so it converts into alcohol, like that. Next to acid, so oxidizing agent I'll be using KMnO4 and potassium dichromate. Further, I also gave how are we going to convert into further products. Let us see the examples also. So this page includes everything, the whole organic chemistry chapter. Let us start with the first type of conversions, that's nothing but step-up conversions. Right? In step-up conversions, what will happen, students? There will be elongation of chain. See here, there's only one methane chain. Gradually it has become ethane. Gradually it has become your butane, isn't it? So this is a sort of alkane conversions where we call them as conversion of methane to butane. Easy, students. So I mentioned the reagent, I have mentioned what is the type of reaction, what will happen when you use free radical halogenation, and finally with Wood's reaction. So please note this chart, students, very important chart. Right, now let us start with your first chapter, that is your haloalkanes and haloarenes. If you see here, haloalkanes, haloarenes, I have taken an alkyl halide for example, and I have shown you different conversions into alkyl halide conversion into amine, alkyl halide conversion to alkene, alkene to alkynes. Next comes alkyl halide to alcohol, aldehyde and acid. Further, I also have shown you how alkyl halides are converted into your primary, secondary and tertiary alcohols also. This is a very important conversion for your complete alcohol chapter students, alkyl halide chapter students. So I have written here, it's a complete alkyl halide conversion sheet. So it's a mind map. Please note it. Let us go to the next chapter, that is alcohols, phenols and ethers. Now let's start with the alcohol conversion, students. So basically in alcohol conversions, we have different reagents which they are used. Here, alcohols can be converted to alkyl halides to alkyl amines. I have shown you the reagent as how you are going to convert. Then I have shown you on alcohols on reduction, because it's a metal catalyst, isn't it? So with the metal catalyst, how this particular hydrogen is lost and you're getting aldehydes. We very well know aldehydes on oxidation gives acids. Like that, I have shown you direct conversions or to acids. I have shown you how this pathway is followed. Then comes how to convert alcohols to amines using your ammonia vapors. Then alkenes, conversion of alcohols to alkenes, alkenes to your vicinal dihalides to alkynes. So alkenes to alkanes also using reduction or reducing agents like metal. Let us come and see the next chapter. Now let us start with the next topic after alcohols, that your carboxylic acids. Right, students, first we will complete all the aliphatic conversions, then go to the aromatic conversions. So in this particular thing, we have seen with different name reactions like the Clemmensen reduction, I am preparing alkanes. With Wolff-Kishner reaction or reduction, we are preparing alkanes. Suppose if I introduce HI and red phosphorus and using sodamide, that also, this is one reaction, this is one more where I prepare alkanes. So for preparing alkanes, you have 1, 2, 3, 4, 5 methods to prepare alkanes. So I have listed everything in one place. Next, alcohol, carboxylic acids can be converted into alcohols using a reducing agent like lithium aluminum hydride. Then you can use it using ammonia. You can convert it into aldehyde. Then comes esterification reaction where acid plus alcohol forms an ester. So these are the different. Let us see one more. This is one more part of your carboxylic acid conversion, where carboxylic acid conversion, I think it is visible. So here you can convert carboxylic acid using ammonia, right? And your conversion into acetamide, and using Hofmann's bromamide degradation you can convert into 1 carbonless amine. So this is one more type of conversion, students. Now let us come and see the next chapter. Let us come and see the next conversion, that is aldehyde conversion, students. So here aldehydes can be converted to alkenes using Clemmensen reduction. Aldehydes on oxidation gives us acids. Aldehydes on reduction gives us alcohols. Further, you can convert the alcohols into primary alkyl halides using PCl5 as well as using a dehydrating agent. How do you do this? You're going to remove OH from here and you're going to remove hydrogen from here. So you're removing HOH here, and finally you're going to get an alkene. So further, this alkene in the presence of bromine, suppose you're adding dibromine, means bromine atoms you're adding, double bond will break and you'll get 2 vicinal halides, and you do add alcoholic KOH. So this is nothing but beta elimination, students. So beta elimination, you will be getting alkynes. So this is a complete chart of your aldehyde conversion. Now let me show you one more. This is nothing but amine conversion, students. So maximum the whatever amines conversions are there, everything will come in under this. So here what did I do? I have taken primary amine. I have shown you how to convert. This is nothing but your diazotization reaction, students. So where aniline or aliphatic amine or aromatic amine is converted into your BDC. Further, you're going to use red phosphorus, or if I have to tell you, in the presence of copper chloride or copper bromide, like that. Okay, you'll be converting it to the respective halides. So I have shown that BDC. Further, one more procedure. So this will give what, students? This is going to give you your alkyl halides. Like if I take RCH2X, X can be chlorine, bromine, right? Sign also. Now in this case BDC, I'm converting into alcohol using hydrolysis. Further, if they ask you to convert, see in the question is given, convert primary amine to alkane. This is one procedure. Further, you can convert the alkane to nitroalkane, again back to this. So isn't it easy? I've taken the whole nitro. Let us see the next aromatic conversions also. Next comes your aromatic conversion, students. So first I have taken chlorobenzene, where all the reagents along with the temperatures I have mentioned here. You're able to see all the reagents. Reagent, temperature. So how chlorobenzene is converted to phenol, how chlorobenzene is converted to aniline, benzonitrile, toluene, biphenyl, using Fittig reaction, because 2 aromatic rings combine, isn't it? Right? So here what will happen? 1 chlorobenzene is there. I'm going to introduce one more chlorobenzene here so that you get biphenyl. Then comes, and using magnesium and ether, you're going to prepare Grignard's reagent, ARMGX, or aliphatic if you take RMGX. So here again reduction. By reduction process, you can convert chlorobenzene to benzene. Perfect. So these are the preparation methods, students. How can I prepare? So these are the preparations, these are the conversions, right, students? These are the conversions. Now let us come and see the next one. Now let us see one important conversion of chlorobenzene, students. If they ask you convert chlorobenzene to ortho-dichlorobenzene or para-dichlorobenzene, direct introduction of chlorine, because it is OP directing group. That's fine. Here same thing, if they ask you to prepare orthosulfonic acid or parasulfonic acid, you're going to use sulfuric acid, and this is an electrophile which is going to add. Because it is ortho-para directing, simple, we have written both at the ortho position and para position. That's easy. Now I'm showing you benzene conversions. Just see, students, right? Benzene conversions, little bit, let me adjust. Let us now see benzene conversions all together. So basically these are the preparation methods of which benzene, how I can prepare benzene, either from, BDC or from alkynes, from phenols, from chlorobenzene, right? And here using your sodium salts, where I'm using soda lime, right? So here I have shown you completely how can I prepare benzene from these compounds. Further, benzene, you all know students, it can be, because it is a delocalization of pi electrons, you can do sulfonation, you can do chlorination, right? You can introduce, or if you have to tell you, in the presence of nitric acid and consequently sulfuric acid, you can do nitration. Perfect. Ortho product, meta product also you get 2,4,6 tri or 135 tri nitrobenzene also you get. So I have also shown you a zoonolysis where you are adding ozone, and further on reduction you are preparing glyoxyl. So it's a conversion of benzene to glyoxyl. Further students, benzene can be further done reduction and prepared cyclohexane, right? Cyclohexane is a compound. So 3 2s are 6. So you're adding completely all the carbons. So all the hydrogens are added and this bond goes off. This is cyclo compound. There's no delocalization, and 6 plus 6 will be preparing a cyclo compound. Now let us see further reactions of benzene, where benzene you're getting converted using electrophilic substitution reactions, where you're going to do alkylation, Friedel-Crafts, acylation, adding the acyl group. You're going to do Gattermann's reaction, where you're converting benzene to benzaldehyde. You're also preparing benzoic acid from benzaldehyde. So I have shown all the reactions on this side. Here in this particular thing, I have shown you the conversion of benzene to aniline. How? Using ammonia. I can do that in the presence of anhydrous AlCl3 Lewis acid. Then comes preparation of, if they ask you preparation of cyanobenzene, I can use cyanogen chloride. In the same way students, I can also prepare benzene to amide group using this compound. Right, so that is most important thing. Now let us come and see the toluene conversions. Just check toluene conversions. I think it's visible, right? So this is clear, I think students, right? Now see the toluene conversion. These are the preparations of toluenes. I can prepare toluene using Friedel-Crafts reaction, Wurtz-Fittig reaction. Further, this toluene I can prepare or convert because it is ortho-para directing, ortho group and para group. Chlorination, nitration, Friedel-Crafts alkylation. I have shown all the ortho-para directing groups. Everything is noted. Here there is one compound. Earlier what did we see? 135 TNB we have seen, right? Now it is 2,4,6 trinitrotoluene, TNT, that is TNB. This is TNT. So you should see the type or the nature of the substituent or the functional group what is attached. There it was benzene, here it is toluene. So to differentiate that, I have shown you like this. Let us see the next one. Now let us see the important conversions of toluene students. So basically toluene, they ask you to convert into benzyl chloride, benzyl chloride, benzol chloride. Let us see the difference. So first of all, when you take toluene and you're adding or you're doing chlorination, first one hydrogen from here is replaced or substituted by chlorine, and you get what will happen? Minus HCl. Okay, minus HCl. What will happen? One hydrogen replaced with this chlorine, it becomes benzyl chloride. Further, you're going to substitute one more hydrogen by chlorine, it becomes benzyl. So benzyl is CH2Cl, benzyl is CHCl2. Further, you're introducing one more chlorine to this hydrogen also is replaced, we'll be getting benzol chloride. That's one such type of conversion. Suppose if they are asking you to convert or prepare benzaldehyde from toluene, what is the reaction students? Itards. Itard reaction is used to convert benzaldehyde or prepare benzaldehyde from toluene using an oxidizing agent, that's nothing but chromyl chloride. This is what I mentioned. Suppose if you are using mild oxidizing agent, you will get benzaldehyde. If you are using strong oxidizing agent, you will be getting benzoic acid. So I have given the important thing here. Now let me show you the next one with nothing but your BDC. Students, in haloalkanes BDC is deleted, but in amines it is there students. So you should study the topic carefully. So BDC, you very well know, I can convert BDC into n number of products. What is very important? See here, this is your Sandmeyer's reaction. The first three, CuCl by HCl, CuBr by HBr, CuCN by KCN, or CuCN, CHCN. Wherever you have till here, all these are Sandmeyer's. After that, you only have copper and KCN. That particular reaction is called Gattermann's reaction. So both are preparing your haloarenes and your cyanoarenes, but difference is the metal catalyst. Done. Now here students, next you will very well know fluorobenzenes I can't prepare directly like this. So what do? I have used a reagent that is HBF4. So this is going to get converted into your first unstable complex, then further on heating this one, nitrogen gas is out and your BF4, okay, BF3 also comes out and your fluorine attaches to that BF3, right students? Then this is a procedure to convert BDC to phenol. BDC to on reduction, what will happen? Reduction, what will happen students? You're going to get amines substituted in that, right? So 1, 2, 3, okay, right, substitute in that, that is what is a type of bond. Now let us see one more students. BDC, I can, on using a reducing agent, I can prepare benzene. Benzene in the presence of CO and HCl, we have already, there's a name reaction also for this. You're going to convert it into benzaldehyde. So this is one conversion, reduction. Further, you are going to convert into aniline. So BDC to aniline, this is one more procedure. I have explained you everything. Please note it. Now, let's see some more conversions of BDC, where BDC you're converting into fluorobenzene. You can convert using a reducing agent into aniline. You can use copper powder to convert BDC into nitrobenzene. So, I have shown you all the combinations where your BDC getting converted to different products. Right, students? Now, let us see for phenol. Right? Right. One more aromatic conversion, students. So, for phenol, if I have to see here, phenol can be converted into n number of products like benzene, 2,4,6-tribromophenol, ortho and para-nitrophenol, only phenol. So basically, students, in the reduction, when we see reduction process, the same like how are we converting the product into different compounds using Friedel-Crafts acylation reaction, okay, Friedel-Crafts alkylation reaction. Fine, students. So again, concentrated nitric acid forming 2,4,6-trinitrophenol, then dilute nitric acid, you get ortho and para product. So with bromine, see here, bromine water, all the three sides, ortho, para and 2,4,6, ortho, para and ortho sites are occupied. Here ortho and para with dilute HNO3. So this is with let us not take this. Let us see this compound, students. Okay, so concentrated means 2,4,6 trinitrophenol. So I've shown you the complete reactions. Now let us see the last one. Students. Yes, let me adjust. I'm showing you the last one, students. Just check. Potassium dichromate, right? For the CBSE students, it is not there, but for the ICSE students, very important. So potassium dichromate getting converted to chromate. It being an oxidizing agent, this is going to oxidize iodide to iodine, Fe+2 to Fe+3, HCl to Cl2, where here it is -1, oxidation state is 0. With concentrated sulfuric acid, dichromate to chromate, oxidation. Further, these two products also have given. Sulfur dioxide to sulfate, conversion. Chloride to your, chromyl chloride, right? So, I have shown you all the conversion, students. So, all-in-one conversions, what did I include? Let me show you this page. I have converted all-in-one conversions for all these compounds. So, please note it. Very important thing, students. So I am expecting you. I think this particular conversion will be useful for CBSE. It will be useful for your NEET examination, JEE also. It took a lot of time for me to prepare. Please share the video, subscribe to the channel, and I request more and more students to join WOC. All the best for your exam, students. Vani ma'am will come back with one more important video for your board examination. Please join me every alternate day live in the most expected series which is going on between 3 p.m. to 4:15 p.m. Thank you so much. So welcome back, students, to the conversions of your NCERT. Basically, most of the students, if I have to say, you feel conversions is the most difficult part of the organic chemistry, but they're very easy. Why? I'll tell you the reason. Now, in your NCERT textbook, when you see in different chapters, you have conversions, right? You have more than 10 or 15 types of conversions. For everything, there's a link, actually. If you know the link and if you remember, okay, how to do the conversions, when cyano is given how to do, when methyl is given how to do, this is where I made the complete flow chart for your conversions which are there in your NCERT. If you try to practice all these conversions, it's easy for you to solve any type of conversions given in the board exam. Right. This is combination of all the chapters of your NCERT, that is haloalkanes, haloarenes, alcohols, phenols, ethers, aldehydes, ketones and carboxylic acids, as well as your amines also. So everything together, all the 4 chapters will come under this. So basically your conversions are divided into aromatic conversions as well as aliphatic conversions. Done? Yes. So when I come back to aromatic conversions, these are the list. This list is not given in your NCERT. I tried to find the links between different types, and this is how you're going to learn, right? Everything will be covered in a detailed way. Don't be in a hurry to complete the conversions. It's going to take 4 to 5 days for us to complete. We will learn clearly. So when I have to come back to the aromatic conversions first, for your grade 12th syllabus, you have conversions starting from benzene would be the base product. So base, if I have to say base compound. From benzene, we are going to prepare, they'll be asking you to convert from benzene all these. Benzene to toluene, benzene to chlorobenzene, again chlorobenzene to paranitrophenol, then benzene to N,N-dimethyl-aniline, benzene to diphenyl, benzene to metabromophenol, benzene to methyl benzoate, metanitrobenzoic acid, paranitrobenzoic acid, and metanitroacetophenone. These are the basic conversions which they're going to ask you. This is given under different types, different parts of the textbook. So I clubbed together so that's easy for me to teach. This is a basic conversion for benzene into these. Now you also have to learn the conversion of benzene to aniline, then benzene to toluene. Now here benzene to aniline, again we have conversions of aniline into chlorobenzene, 1,3,5-tribromobenzene, benzyl alcohol, 2,4,6-tribromofluorobenzene, parabromoaniline, phenyl isocyanide. So this is your isocyanide test done. So I'll be teaching our carbylamine reaction. So I'll be teaching these conversions. Why did I pick up like this? If I pick up like this, it's easy for you to analyze. More than this, you'll not be questioned. All the combinations will come under this. Done. Now next, when I come back to benzene to toluene, again you have 2 things. Toluene is further converted to benzoic acid. Benzoic acid is further converted to benzaldehyde. That means there will be one conversion of benzene to toluene. They may ask you like that, or they may ask you toluene to benzoic acid, one conversion. They may ask you benzoic acid to benzaldehyde. Done. Now further, benzoic acid is again converted to metanitrobenzyl alcohol, aniline and benzaldehyde. Now benzaldehyde is again converted into, or they'll ask you to convert benzaldehyde into, that is your C6H5CHO, benzaldehyde into 3-phenyl propanol, benzophenone and 3-hydroxyphenyl acetic acid. Don't get panic with so many names. I'll show you how to convert them, how to remember also. But remember one thing, don't be in a hurry to complete. I want you to learn it carefully so that you will not lose those 3 marks in the exam. Done. Now after that, you also have conversion of ethyl benzene, acetophenone, bromobenzene and phenyl ethene to toluene. Done. So I want everybody to note this aromatic conversions heading. I'll be starting with conversions from tomorrow. I want this to be ready with you so that whenever I complete, you can put a tick like this in the paper, right? Prepare like this and keep. And next you have aromatic conversions. One more conversion, that is benzyl chloride. Benzyl chloride to 2-phenyl ethanamide and benzyl chloride to benzyl alcohol. So these are the aromatic conversions which we have. Yes, so let's please note it and keep it. Now let's come back and do aliphatic conversions. When I come back to aliphatic conversions, basically your aliphatic conversions, if I have to say, maximum 15 are only there. It's easy for us to know. So why here basically your aliphatic conversions of the straight chain compounds, they are divided into different parts in different parts of the book. So everything I've clubbed in together, put on a common platform, so that's easy for you to remember. So the first step of aliphatic conversion is propanone to propene, propene to propan to all. Right. Next one. They're asking us to convert Grignard's reagents to propanol,
2-chloropropane to propanol. Both the combinations they may ask you. More than this, they will not question you. Next, again, they've asked you Grignard's reagent to convert to 2-methylpropanol. Please keep noting everything like this only. Tomorrow, once I start, it's easy for you to remember. I'll tell you what are the keywords to remember. Next would be 1-bromopropane to 2-bromo. Very famous reaction, famous conversion this is. Done. Next, I'm going to teach you what is the conversion of 2-chlorobutane to 3,4-dimethylhexane. Next, propanoic acid to ethanoic acid to propanoic acid. Both the conversions I'll show you. Then I'll be teaching you how to convert nitromethane to dimethylamine. Done. Next one, ethanamine to methanamine and methanamine to ethanamine. Both the ways. They may ask you like this or they may ask you in the reverse order also. Next would be conversion of methanol to ethanoic acid. This is one. Next one, ethanoic acid to propanoic acid. So 2 carbon to 3 carbon. From propanoic acid, that is your final product. Now they may ask you basically to convert haloalkanes, that is ethyl chloride to acids. We are really trying to relate the first chapter with the fourth chapter, fourth to second, second to third, like that. Now there is one more type of propanoic acid conversion. Here it is. See here, they may ask you, for example, okay, I've added that also here, isn't it? Okay, done. Right. And now next important thing, 2-methyl-1-propane to 2-chloro-2-methylpropane, introducing the chloro group into the this straight chain. That also I'll show you. After that, in the 11th reaction, I have chloro. This is nothing. I've just typed it off. Okay. 11th one, chloroethane to butane. Then tertiary butyl bromide. Mostly they are with your haloalkanes to further. So tertiary butyl bromide to isobutyl bromide. Next, you're going to write 1,2-dichloro. If I have to take, this is butane, isn't it? Right. So you can also write butane 1,2-dichloride. Okay, this is basically dichloro and 1,2. You can write both the ways. Into hexane 1,6-diamine. That means the 6 carbon atom and hex. It is a 6 carbon atom means hexane and both the sides amine. It is like this: NH2 single bond, CH2 taken 6 and NH2. This is hexane 1,2-diamine, both the sides. Next, ethanoic acid to methanamine is one. Here they are relating carboxylic acids to amines. Next, I'll be completing the aliphatic conversions with hexane nitrile to 1-aminopentane. That's it. So these are your aliphatic conversions. So let's come back and meet with all the conversions step by step. Let us go in a detailed way. Let us come back and start with the first conversion of your organic chemistry. Already I have given you the index, how to go about with all the NCERT conversions. Now let's start with the first basic conversion. Now in the exam paper, if they give you to do benzene converted into toluene or benzene converted into aniline and toluene to benzoic acid. This is a basic conversion which you have to learn first. If you know this basic conversion, then I can take with different variations. Now what do they give you? They've given you benzene. Pick up benzene, write the benzene structure. Okay, now what do they ask me? This, okay, so this is your benzene structure. Now what do they ask me? They ask me to convert this is into toluene. Then write the toluene structure. I'm going with the first equation. Now this is your CH3 toluene. So let us write as toluene. Done. Now from here till here, what is extra? This is your group. Methyl group is extra. So we very well know whenever I have to write methyl group extra or this add to methyl group, I can do a process called alkylation. Alkylation is a method to convert benzene or add this methyl group. In alkylation, what are we going to add? We're going to add methyl chloride in the presence of what? Anhydrous AlCl3, this which we have done, which acts as a Lewis acid. Done. Now I'm taking this toluene. What do they ask me to convert further to benzoic acid? So I'm going to write benzoic acid. Simple. Write the formula. Now what is extra? See here. This is your CH3. This is your COH. From CH3 I need to convert into this. That means I need to add this group to this. From alkyl group I need to convert it into acid. So always remember the basic alkyl group. To convert it, see, I also already told you one time. What is that? If you pick up, right, here oxygen is there. I need to take an oxidizing agent, that is KMnO4. Along with that, we very well know to convert alkyl group, I can't directly convert it. I should use KOH, potassium hydroxide. Then what will it be converted into? It will be converted into your COOK immediately. Now further, to convert from this to this, because this has converted, added to this as COOK, and the leftover, because this is oxidizing agent, you got oxygen in the presence of potassium hydroxide, potassium, COOK. Further, if I have to convert this to this, you are going to add hydronium ion. When you add hydronium ion or H3 plus acidic medium, but from this potassium is lost and you get benzoic acid. Simple, isn't it? I got the first basic thing. So now from benzene to aniline. So I have to convert this. First let us write. So this is what I have to prepare. Aniline. Now see, come back. Benzene, there was no group, right? Directly amine is introduced into this ring, isn't it? So what should I do? What did we learn? We have learned one reaction where you're converting benzene, right? You can directly say, how can you introduce? You can go through BDC structure also. Benzene converting using NaNO2 HCl, you will convert it into your BDC, benzene diazonium chloride. That benzene diazonium chloride, further if you heat, you will get nitrogen gas out and chlorine. But what happens, the basic or easiest thing is, when you have benzene, where we have studied in grade 11, you can do a reaction called nitration reaction. What is that? Nitration in the presence of HNO3 and H2SO4. What is the electrophile? NO2 plus. Okay, right, this is your NO2 plus. That we very will always remember. Nitro, it is converted to aniline. Remember that. First is nitro group. Okay, we'll write here NO2. Then after that NH2. So from here till here, what are you observing? Nitrogen is there only here. Instead of oxygen, this hydrogen. So which one will add hydrogen? Reducing agent. So SN by HCl is a reducing agent. So this is your first type of conversion. Now after the first type of conversion, where I've given in the index, now let's come back and start basically reactions of benzene. So in reactions of benzene, let me pick up one conversion after the other. So in the exam paper, they've given me to convert. Okay, let us write the first one. Convert, if they give you like this, benzene, convert it into, if they're giving you 4-nitrophenol, this is what they've given me. Okay, so simple, don't get panic. Just write the structure, right? Benzene here, this, and they've asked me to convert into 4-nitrophenol. So first write phenol, and fourth position 1, 2, 3, 4. Fourth position is nitro. Now I have to convert this to this. So first basic important thing, what should you remember? Compared to this one, there are two groups which are introduced in the product. These two groups should be introduced step by step. How can I introduce these? First important thing, this is a nucleophile, isn't it? That means this nucleophile OH should be replaced again with a nucleophile first. That means from benzene, I'll add chlorine nucleophile in the presence of anhydrous AlCl3. So what do I get? I'm going to get chlorobenzene. Done. So let us write the name of this. I'm coming almost closer to this. To this chlorobenzene, I have to convert this into phenol, means alcoholic group. What am I doing to do? I should also introduce this. Let me add this and then come back. So to the chlorobenzene, we very well know to add nitro group. What should I do? I have to take HNO3 and H2SO4. Then what do you get? You're going to get two products. One is chlorine, one is NO2. Done. What am I going to do? Now what else is left? I have to introduce only OH, isn't it? Right? That means sodium hydroxide can easily replace Cl as this one. So I'm going to introduce sodium hydroxide at 443 Kelvin, right? At dilute HCl. So now what will happen? NaCl would come out and NaOH is introduced. That's it. So I've got 4-nitrophenol, isn't it? Simple. You have to remember what to get. To get this, what should I add? Step by step. Okay, let us go back and do the next one. What did they give me? Here I have to convert next type, benzene. I need to convert benzene to N, dimethyl aniline. This is what they've asked me. So what should you do? Write the formula. This is your benzene ring here. I need to convert N, dimethyl. That means in the benzene ring, at this position, I have nitrogen. To this, I have two methyl groups. Basically, it is NH2. Amine, aniline. To that NH2, those two hydrogens are replaced by methyl groups, dimethyl. This is also over. Now you can start. Fine. From here till here, when I compare, what is extra? Nitrogen is extra. And what is extra? Methyl group is extra. Done. So what did I say always? The first easiest way is to convert. Always remember, to introduce nitrogen or to introduce aniline, you need to come back from nitro group then to aniline. That is what we have studied, isn't it? Nitro group to amine, from amine to this step. That is what is this one. Nitro to amine, amine to whatever further you can do. This is just this one step. Now start with the first one. You're going to do nitration, NaHNO3, H2SO4, nitration. So when you start with this, what will happen? You're going to take this, you're going to get this benzene ring, NO2. After this NO2, you are going to just, I said nitro to aniline. So compare nitro to a hydrogen. What is extra? Hydrogen. What will add the reducing agent like hydrogen in the presence of palladium, and you can take ethanol as a solvent. NO2 is reduced to NH2. NH2. Done. Now compare NH2 to this dimethyl aniline. What is extra? Methyl group is extra. That means these methyl group should be introduced, right? So now let us come back step by step. The first step is I'm going to introduce CH3Cl, because this is where you're going to get alkylation. So this comes out as HCl and methyl group goes and attaches. So what am I going to get? I'm going to get N with one hydrogen and one CH3. Further, I am going to introduce one more methyl chloride. This hydrogen and this HCl comes out as HCl, and you get this compound. So name this NN dimethyl aniline. Simple, isn't it? We are just trying to analyze the things. Let us do the next one. Next one, they've asked me to convert benzene, all benzene conversions. They asked me to convert benzene into diphenyl. Okay, I should know the formula basically. So how to write? They first write the structure. This is benzene. Now what did they give me? They've asked me to write convert in diphenyl. Diphenyl means two phenyl rings linked together. One phenyl ring here and one more phenyl ring here, both. So this is diphenyl. How will I write this? Now what is extra? This benzene, there is one more ring, means one more benzene ring attached. So now simple important thing, which one will get such type, how can I add? I can use Woods reaction to this, isn't it? So Woods reaction is this, but which Woods reaction? Is it Woods? If I take Woods, I have to take two alkyl halide. Here there are two benzene rings, so I can go with Fittig reaction. Fittig, where you have both benzene rings only, isn't it? That is what should happen. Now to this benzene ring, right, if I add chlorine, if I have to add FeCl3, done. So now what will happen initially? Because Woods reaction, Fittig reaction, what is the condition? One aryl halide, one aryl halide together in the center. We need sodium so that both will combine and 2 NaCl will come out. That is what we have studied, Fittig. So I am adding chlorobenzene like this. Now to this chlorobenzene, now I am going to take it as 2. To this I am going to add Na. How many NAs? 2 NAs. So you'll get this. Basically, how is this reaction? It is your Cl plus Na plus Cl. So both will come out 2 Na. It will come out as 2 NaCl, and your phenyl ring is ready. So this is how you have to do. Right. Now let us come back and see the next type of conversions. Hope till now you would have understood how to start about in the exam. Now let's see this. Now they've asked me to convert benzene to metabromophenol. Let us write the formula first. I have to write benzene. Okay. Then what should I convert it into? I have to convert it into metabromophenol. So let's write that metabro. Okay, let me take some space. Okay. Metabromophenol. So this is para, this is ortho, this is meta. So in the meta position we have Br and it is normal phenol. So let us write the name of this, metabromophenol. Now what extra is there in this compound? Here you have benzene, you have an OH group and you have a Br group. You need to introduce both these groups to this. Now I very well said first important thing is, before you get this phenol, you need to have a nucleophile Cl to replace this. Okay, you should have a Cl, then you will pick up some base to take out that Cl and come back. Okay, this work I can do. And after that, to introduce bromine, I can do bromination reaction, right? Isn't it? Now let's see. But to get that Cl also, right? Before that, what is the procedure? First, you do nitration. It's easiest way. From nitration, you'll convert it into aniline, amines. From amines, you can introduce your Cl group and that thing or Br group, and then finally, okay, let me explain what I'm trying to say. So to introduce these two groups, first basically try to do nitration, HNO3 and H2SO4 nitration reaction. As soon as you do nitration, I can introduce NO2 plus to this, right? So this is your NO2. Now, an NO2 always converts into the NH2. That is what we've studied. But before that, let me introduce bromine. How can I introduce bromine? I can introduce Br2 and FeBr3. To this thing, now easily nitro is there and your bromine is here. Now, next thing, I have to convert the nitro group to amines. How can I convert? I have to remove oxygen and add hydrogen to this. Which will do that? Reducing agent. What are the reducing agent? Either you can take Sn by HCl or Fe by HCl. This is a reducing agent. What does it do? It immediately from nitro it adds to amines. Here bromine. Done. Now bromine, I have to convert this NH2 amines to alcohols. So what is the thing I said? OH should be replaced by Cl. That means there should be a group which introduces Cl, isn't it? What is that group? I'll go with a reaction where I'm introducing NaNO2 and HCl. When I take NaNO2 and HCl, what will happen? Yes, simple, isn't it? We are going to convert using Sand-Meyer's reaction. We are going to convert amines to BDC. Amine will become N2Cl and Br is still there. Now this N2Cl, what will happen? I can warm it. Just warm. When you warm it, right, in the presence of water, so this nitrogen gas escapes out. H will come out as Cl, and what else is left? OH. Once again, nitrogen escapes out. H comes out as HCl, and the left OH is here. That's it. This is the reaction. Let me see one more type of reaction here. So when I have to see the next type of reaction, if they ask me to convert benzene, right? So basically I'm trying to do all benzene reactions only. Here they've asked me to convert benzene into methyl benzoate. Methyl benzoate. How should I do this? Let me write this formula first. First you're going to take benzene. Write the formula for methyl benzoate. Let us write that. This is your benzene ring. Methyl benzoate is it. That means with benzene ring, benzoate is COO. But this is methyl benzoate. Methyl benzoate. So let us write that. Methyl benzoate. Benzoate. Done. Now let's see. What is the group which is added to this? From benzene, we have added CH3 group. From benzene, I have added COO group. Okay, this is an ester, isn't it? COO. So what should be there? I have to do a process called esterification reaction. Okay, before this, done. So first basic thing, before I have to reach this point, I need to start from here. What is the first thing? To this group, but this particular thing, extra is ester. Okay, esterification, but there is one group, methyl group also added. So whenever you are adding a new group to this, you need to use Grignard's reagent, addition compounds. So first important thing, try to prepare Grignard's reagent. So what can I do? I am going to introduce bromine to this in the presence of FeBr3. Then immediately I am going to get bromobenzene. Now I am going to add Grignard. I have to prepare Grignard's reagent, magnesium in dry ether. Then what do I get? I am going to get MgBr. Done. So to this MgBr, what should you do? I said you have to introduce. Now this Grignard's reagent is ready. Now I need to add this group, isn't it? This group and this group. I have to be careful. To add to this group, I am going to introduce, we have studied in Grignard's this one, carbon dioxide and in the presence of dry ice. That is here dry ice. So what do I get? I am going to get a compound which is C double bond O MgBr. Done. So I am gradually coming closer to this. This MgBr, if I have to take. Now H3O plus. Why did I use H3O plus? In the presence of acidic medium, I can convert this into COOH. I'll tell you why I did this. Because the COOH group, here I said esterification reaction. Esterification is a combination of acid plus alcohol. So here what can I do? I can use CH3OH. So which is this reaction? This is called esterification reaction. So I am going to take out water from here. And what do I get? I get ester. That is methyl benzoate. Done. So concentrated sulfuric acid also. So concentrated H2SO4 also. This is it. So these are the complete reactions of benzene, the maximum conversions rather to your whichever product they ask you. Benzene conversions basically. So after benzene conversions, gradually let us go into the next type of conversion which I gave in the index. So what is that? Now benzene to different types of combinations I have studied. Now let me teach you like if I have some other, okay, in the paper I have given you many other conversions also, combinations. Let's see all the combinations one after the other. I thought, okay, we will do that combinations also, you will understand. So here what will happen in the exam paper, like let me underline, if they give you one more with benzene, let me try. Benzene to meta nitrobenzoic acid. Meta nitrobenzoic acid. So this compound is given to me. So what should I do? First I'll write the name of the compound, that is benzene. I'm going to write the name of the compound, benzene, that is meta nitrobenzoic acid. This is your COOH. At the meta position you have NO2. This is a compound, right? Now, so now what I'm going to do, I have to introduce COOH group, I have to introduce NO2 group also, these two, isn't it? So to introduce these two groups, what should I do? First I have to introduce which one extra is which, this carboxyl group. Suddenly I can't get COOH group, I need to introduce from somewhere, which will add your what do you say, Grignard's reagent will add this, isn't it? Grignard's reagent can easily add this carbon. So come back, start from Br. When you add Br, what will happen? It will come back, or this Br adds to this. Now further I am going to add magnesium in dry ether. When I add magnesium in dry ether, what will this become to? This will become to MgBr. Grignard's reagent is almost getting ready. Now from here I am going to take carbon dioxide and dry ice. So when I introduce carbon dioxide, see, gradually I am trying to introduce this group into this. So COOH group. Now this comes to COOMgBr. Done. Fine. So after this, next important thing, gradually now we are trying to see to convert this one to this group. What can I do? I have to take out MgBr, then only I'll get this group. Now I can introduce an acidic medium to this. When I introduce an acidic medium, I am going to get that is lost, and you're left with this. This is basically like HOH. If I take this becomes COOH, and you will get MgOHBr out. Then benzoic acid. Still it is not complete. I need to introduce NO2. To introduce NO2, we very well know we are going to use nitrating mixture, concentrated HNO3 and concentrated H2SO4. That's it. Your conversion is done. You're converting benzene to metanitrobenzoic acid. Let me see one more type of conversion. So when I have to see the next type of conversion, what did they ask me? They've asked me to convert benzene to para nitrobenzaldehyde. Okay, let's start. First I have benzene, right? I have para nitrobenzaldehyde. Let me write that. I have a benzene ring with benzaldehyde and NO2. Now what should I do? I have to add your carbon, this carbon and this group, and after that I need to add nitro. Okay, nitro I can easily add with nitrating mixture, but one important thing is you have to see that you are doing it sequentially. Let's see how to start. So benzene is there with me. To introduce this group, simple, I have to first do alkylation. Why should I do alkylation? Because your anhydrous AlCl3, the benzene, see, directly nitration, no. First try to add this group, then come back to this group. Now alkylation, if you do, you get toluene. This is toluene. From toluene, what do we do? Gradually, you have to see that this group, from here, there is nothing here, nothing here, nothing here. I have to come to this group. This is your HNO3 and H2SO4 nitration. Then what do you get? You are going to get benzene ring CH3 with NO2. Now from this to this I need, we very well studied one, that is your chromyl chloride. In the presence of chromyl chloride, we have done one name reaction also. Hope you remember Itard reaction, I believe. Yes. So we can do chromyl chloride, that is CrO2Cl2 in the presence of carbon disulfide. This group with the Itard reaction, I have shown the mechanism also. This becomes CHOCrOHCl2. Further, if I have to take, I'm only left with this group. This group I can nitro is also there, NO2. Compared to this group, if I have to take out, I have to get this, that means I can do acidification, H3O plus, or it is HOH rather. What will happen? This O group goes and adds here, and this comes out, which I've shown already. So simple, I got para-nitro benzaldehyde. Let us finish the last type of conversion with benzene. That is, here they've given me benzene to meta-nitro acetophenone. Okay, why such a big name? I have to remember acetophenone. So what is this? How to do this? First, try to write benzene. Meta-nitro acetophenone. Let us write the name of that. This is, see, they said meta-nitro acetophenone. They said done. Let us write acetophenone. Okay, meta-nitro acetophenone. Acetophenone formula, it is COCH3. This is acetophenone. If I take meta to that group, meta-nitro acetophenone. Now what should I do? I have to introduce which group? I have to introduce NO2 group, which I can do with nitration. I have to introduce this group, which I can do with acylation. Simple, isn't it? So first thing, try to do nitration, HNO3, H2SO4. Then immediately I am going to get benzene NO2. Then what do? I am going to do acylation reaction. How can I acylate? CH3COCl, which we have studied. Acyl chloride. Right, I can take this in the presence of anhydrous AlCl3. Anhydrous AlCl3. Then immediately this big H of this particular thing, and COCH3 goes and acts. So I am going to get meta-nitro acetophenone. That's it. Right, let's come back and start with your aniline conversions. Okay, so aniline, hope everybody knows the formula, right? C6H5NH2. Now in the exam paper, if they ask you like this, just see what can I do. Suppose if they ask me different types of conversions, I'm first write aniline like this, and after that let me pick up different examples at a stretch. Let me take the first one here, let me take the second one here, let me take the third one here. What did they ask me in the exam paper? They've asked me convert aniline into 4-nitrophenol. This is what they've asked me. Nothing to get panic, just write 4-nitrophenol. Let me write that compound first. So this is your benzene. Phenol, they said OH. So 1, 2, 3, 4. The fourth position, nitro. Now when you compare amines and phenol, what is extra? You have OH group extra, you have NO2. So for me, introducing NO2 is easy because from aniline I can directly convert it and then finally come to NO2. But what is important, I asked you to start from here, 1, 2, 3, 4, then come back to this. So OH group should be introduced. I said OH is a nucleophile. You need to replace that with one more nucleophile. Nucleophilic substitution reactions, that is Cl. Which will introduce Cl? You can use your Sandmeyer's reaction or Gattermann's reaction, so Cu by HCl or CuCl2 by HCl. Done? So let me start. First I need to introduce this group, that is from Cl. So for first I'm going to take aniline, convert it into first easiest way to get that, convert it into BDC, that is N2Cl. How did I get N2Cl? I'm going to introduce NaNO2 by HCl. This is BDC. Why did I use this? Because here already chlorine is there. This chlorine will replace OH. So now when I am going to heat this, or further if I have to treat, I can also use Cl by HCl. Then what will happen? This Cl, that HCl comes out and you get nitrogen escapes out and you are left with only chloro. Now this Cl has to replace this OH. So what are you going to do? You are going to take HNO3 by H2SO4 concentrated. Then this Cl will be replaced by your NO2 plus, because nitrating mixture I am going to get this Cl nitration, because we know nitration you get ortho product and para product, both the products. Cl is like that only. I'm going to get NO2 ortho product. I'm also going to get NO2 para product, Cl and NO2. Now what can I do? I have to convert, this is already ready. I have to convert Cl to OH. So what can I do? I can take sodium hydroxide, which is aqueous in nature. Then what will happen? NaCl is out of the reaction. NaCl minus NaCl. So OH is introduced. That's it. I got the compound. So what is this compound? 4-nitrophenol. Let us see one more. Here they've asked me to convert aniline to or amine to benzylamine alkylamine to 1,3,5-tribromobenzene. This is what they've asked me. Then what should I do? First, let me write the formula. 1,3,5-tribromobenzene. This is your benzene. So 1, 3, 5. Okay, if I take this is 1, 2, 3, 4, 5 and 6. 1,3,5-tribromobenzene. Tribromobenzene. So what should I do? I have to introduce these groups from amines. Now, simple. This should be lost. Amine should be lost. Right? That means first I have to convert amines to nitro group. Always that is a thing, right? Nitro. So nitro group to further, how can I remove? Let's see. So now take benzene. Introduce these two groups because there is no other substituent. I can introduce these two groups. How can I introduce? If I can take to this particular compound bromine and water, minus HBr will happen. So I get, you can do bromination also, NH2, 3 bromines are introduced. Now these 3 bromines, I said, convert amines to nitro group always. So what can I do? I can use NaNO2 HCl. So this amine immediately will convert it into NaNO2. Bromine is at first position, bromine in the third position, bromine in the fifth position. Still it is not complete. Now I have still NO2. Then I told you one day in one of the papers, if you use H3PO2 because of water, immediately that is lost. And I said usage of H3PO3, but H2PO2 you get benzene ring. I told that in one of the reactions. So in terms of H3PO2, benzene ring you get and bromine is still there. That's it. Suppose in the exam paper, if they ask you to convert amines to benzyl alcohol, this is what they give you. Benzyl alcohol, what is the formula? You have that benzene ring with CH2OH. Benzyl alcohol. Now, next important. From amines, I have to introduce this group. From where will I get this group? I have to provide this, means this OH, okay, fine. Because alcohol is there, I can get this alcohol from acid. We've already studied inside. Acids on acids on reduction gives alcohols. So I can go with acids. Done. Acid, from where will I get? I need to get it from something like, a group to introduce into that. So let's see how to do. So take benzene. So simple thing, I said, this is your nucleophile, COOH. That OH to be introduced from one more, means one more nucleophile. Basically we take Cl. How to introduce Cl? I can use to this particular reaction NaNO2 HCl. If I introduce NaNO2 HCl, what do I get? I am going to get BDC. Now chlorine and OH I can easily replace. But what is the procedure? I said alcohol, before that you need to get it from acids. Right? So this acid, that means that group should be present. Now what do you do as soon as you get BDC? Try to introduce copper cyanide and KCN. Why did I take this? This nucleophile and this nucleophile gets replaced. So minus N2 is here. This is CN. Cyano is done. Now what are we going to do? Gradually I am trying to reach this compound. So what did we learn once when we did cyano? There are two things. I said complete hydrolysis and partial hydrolysis. I taught you once. So if I take the complete hydrolysis, H3O plus and this, Then cyano group, what will happen? You're converting cyano into acids. Now I'm almost ready. See here, acids on further reduction. This lithium aluminium hydride, right? It's 3O plus. So acids on reduction gives alcohols. Yes, done. Now let's see one more. Suppose if they ask me to convert, what is that? They've asked me, you're going to convert aniline to 2,4,6 tribromo-fluorobenzene. This is what they've given me. So what should I do? Let me write the formula. First, I'm going to take aniline. What is the thing which I require? I require to the benzene ring, I require tribromophenol. So 2,4,6. 1, 2, 3, 4, 5, 6. 1, 2, 3. Tribromo. Fluorobenzene. Right? This is okay. 2,4,6 tribromo fluorobenzene. Now what is extra? Fluorine is extra. Which will provide me fluorine? I can prepare fluorobenzene from HBF4. Basically, we can't prepare directly from, I've taught you in this one, from BDC, you'll introduce that. That is what is fluorobenzene. From that, this one, I have to also introduce BR group, which will get me bromine group, bromination, or I can go with bromine water rather. If I introduce 3 bromines, at a stage I get. Let's start. Let me see. I can introduce 3 bromines. What do I get? I am going to get to this. Okay, this is aniline, right? I get to this aniline. I get 1 bromine, 2 bromines, and 3 bromines. Done. From aniline to further, I have to convert fluorine. I can't directly convert. I said we can't convert anilines to fluorobenzene. I have to introduce to this. First, I need to convert into BDC, NaNO to HCl. Then amines will get converted to N2Cl, BDC, with bromine all present. 1, 2, 3 ends. Now I'm coming closer. I have to convert BDC because bromine will always carry forward, nothing to do with that. BDC will get converted. How will I convert? I have to prepare fluorobenzene, so then I can introduce HBF4. When I introduce, your nitrogen gas is lost. And 1 fluorine from here goes and replaces this chlorine. This is also negative, this is also negative. Then I am going to get, okay, I already have, isn't it? Nothing to write because I already wrote. So what do I get? Nitrogen is lost, HBF3, and then your Cl is also lost, and your fluorine goes and attacks. That's it. This is how you're going to prepare. What is this compound? I have already written the name here, tribromofluorobenzene. Now let's see the next question which I've given in the index. Now suppose they've given me to convert aniline to parabromoaniline. They've asked me to do this, parabromoaniline. Simplest thing. What do I do? First I'm going to write aniline here. What should I do? Parabromoaniline, write the structure. So this is your aniline. Para group this set. So this is para. Parabromoaniline. So parabromoaniline. This is aniline. This is parabromoaniline. Now see, compared to aniline, aniline is there only. Nothing. I need to introduce bromine. Can I introduce directly bromination and finish up? But important thing, to do that, let us see this reaction. While I'll take aniline. Simple. I'm going to first, because we have studied controlled bromination reaction also. You need to control this group, then only you'll get a para product. That is what we have studied. Please go and watch the video. Bromination of aniline. I have explained you controlled bromination, normal this one also. So in that I have explained you a question also. Why do we do controlled bromination? So in controlled bromination, first I am going to take acetic anhydride because I need to block this group. So I'll introduce acetic anhydride to this. When I introduce, I am going to see how am I going to block, because activating I need to see that. First, I'll block by using control bromination. First, there's a cleavage of the bond here, and you get NHCOCH3. Now it's blocked. Now I can introduce bromine to this. What am I going to do? I'm going to introduce to this bromine in acetic acid. because this is blocked. Now this bromine, what will happen? It will go to this para position because that's most stable form. I get NHCOCH3. This is bromine. Further, I need to finish off this. I need to prepare amines from this. How can I do? I have to remove this group, isn't it? How can I remove that group? If I introduce HOH, isn't it? Right, what will happen? Your CH3COOH is out, minus CH3COH. So this H will go and attack to this. So I get para-bromo-aniline. Done. Let me start one last thing. So here, if they ask me to convert aniline to phenyl isocyanide, they've asked me this, phenyl isocyanide. As soon as you see isocyanide reaction, first thing you have to remember is the examiner is going to speak about carbylamine reaction. Carbylamine reaction, you have to do that. So for carbylamine reaction, what is the condition? Let me write the formula first. First, aniline is like this. Carbylamine isocyanide, phenyl isocyanide is what? Benzene ring, right? Isocyanide is NC. So to convert amines to carbylamine, I need to introduce chloroform. By this time you would have studied the carbylamine reaction, isn't it? Chloroform in the presence of base. Then I've already shown you this one also, process, whole thing. Because I have lot of space, I'll put a big arrow, don't put it in the exam. So in the present, go and watch that video where I've explained carbylamine reaction. So you get NC. Along with that, what else do you get? I'm going to get KCl. Okay, right? Right. No. What should we do? We have to see water, isn't it? First, yes, because this is removed. H2 is removed. So you're going to get water, and you're also going to get HCl. So this is phenyl isocyanide, right? Right. Let's come back and start with the next type of conversions, that is benzaldehyde conversions. Now in benzaldehyde conversions, when I have to see little bit difficulty level, let us see a bit different type of conversions here done. So now suppose in the exam paper, now I'll be dealing all with benzaldehyde only. So what is the formula for benzaldehyde? It is C6H5CHO, aldehyde group. So whenever an aldehyde group is present, you need to remember we'll be using that oxidizing agent, or we'll be using a reducing agent. In that way, different combinations we'll be doing and trying to do different conversions. Let's see. So the first one, if they ask me to convert benzaldehyde to 3-phenyl prop-1-ol, this is the conversion. Now what should you do? First, let me write what is this formula. Benzaldehyde, if I have to take, this is the formula, isn't it? Done. What should I convert into? 3-phenyl propan-1-ol. So 3-phenyl, so phenyl group, done. Then this is prop and 1-ol. That means there is a prop 3 carbon chain, 1, 2, 3, and there is an alcoholic group here. Let's count 1, 2, 3, 4. To this carbon CH2, to this carbon CH2. So this is 3-phenyl propanol. Done. So now what should I do? I need to convert this. Now what do you have here? As I said earlier, you have aldehyde group. Now you need an addition of this carbon chain to form, that is the first concept. After that carbon chain, from what is this functional group? This is an alcoholic functional group. You have to be very careful now. So when you have alcoholic functional group, you need to use an agent to convert. Done. Let's start. So benzaldehyde, first what do? You're going to add this whole group first. So what do I take? I'm going to take acetaldehyde, CH3CHO. So addition of benzaldehyde and addition of acetaldehyde. Here are we not doing cross aldol condensation? This is called cross aldol condensation. Cross aldol condensation. This has to occur in the presence of dilute sodium hydroxide. Now when I'm adding the whole thing here, this is the. Now what do you have? You have CH, first one. Then you have double bond. You have, now what actually is this? This is an aldol condensation reaction. You need to see the mechanism. See the mechanism clearly, you'll understand. There is a shift of hydrogen from the alpha hydrogen to the oxygen. Then it forms OH. Then we are eliminating water molecule. That is why we are getting an alkene here. So CHO, this is the thing. Now from aldehyde, what should I do? I have to convert this whole group. 1, 2, 3 already. 1, 2, 3 already. I need to convert it into alcohol. What can I do? if I have to take this, it's basically CH2OH, isn't it? So I'm talking about this carbon here, I'm talking about this carbon here. Now to compare to this carbon, I'm adding one hydrogen into this, I'm adding here this and one more hydrogen here. Addition of hydrogen is nothing but reduction, isn't it? So reduction will occur in the presence of reducing agent like lithium aluminum hydride or SN by HCl. In this way I'm adding two hydrogens. This is what is the conversion. Little bit higher we will go, because one thing you have to remember is aldehyde, you are asking to find out the further aldehyde, try to go back and do aldol condensation, which adds the chain. Now the next step of conversion, if they are asking you to convert benzaldehyde to benzophenol, very famous reaction. This is benzaldehyde to benzophenol. Let's see. So benzaldehyde, what is this? I have CHO. Done. Now what is benzophenone? This is a thing. This is your benzene ring, and after that you need to prepare benzophenone. That means there are two rings. Along with that, oxygen is present in the center. Benzophenone. This is one ring. This is also one ring. Phenone, isn't it? C double bond O. This is benzophenone. Right, now just see. Now what is extra compared to this? First, this is an aldehyde group, this is a ketone group. Now second important thing, I need to add one more benzyl ring to this. So there should be some reaction or some reagent to get this benzene ring. Now first thing, what am I going to do? Try to convert. First I'm trying to introduce the oxygen group into this. So simple, isn't it? I'm going to perform oxidation reaction using the oxidizing agent HNO3. When you use this aldehyde on oxidation, what will happen? You'll add one oxygen here, one oxygen, right? This is basically oxidation. So what will happen? Aldehyde you're converting into acids. This is what? Benzoic acid. Now this I'm almost coming closer. Now to this benzoic acid, gradually what should I do? I have to take out this one, isn't it? Hydrogen. Why? Because I need that ketone group. Careful. So to take out that hydrogen, I'm going to introduce thionyl chloride to this. Thionyl chloride. So that means directly HCl is out. H and Cl. Yes. And sulfur becomes a sulfur dioxide gas. This is also over. Now what do I get? I'm going to get this compound COCl2. Okay, if you are only taking sulfur dioxide, SO2, gradually in one more step you can also take out Cl, HCl, then this becomes CO, isn't it? Done. So I'm just doing this step. You can also take out like this, just done. So Cl also subtracted, that also I have taken out. Now to this compound, what am I going to do? Because this should not be alone like that, I am adding to this only one benzene ring. This benzene ring I am adding in the presence of anhydrous AlCl3. These two together will join and form benzophenone. So basically I've taken out this here SO2, HCl, right? Okay, then I'm left with what? 1 Cl. So I can write that 1 Cl. Then right now this part is done. In further step, that HCl also will be removed out. So I have written that initially only. Now next type of conversion, let me see if they have asked me to convert benzaldehyde to alpha hydroxy phenyl acetic acid. Okay, such a big name. Let's see what is the formula first. Acetic acid. Now benzaldehyde, as usual, this is the name, isn't it? Let me write the formula. Benzaldehyde is this CHO. I have to convert this into alpha hydroxy benzaldehyde. What is this? This is your thing. Yes, alpha hydroxy phenyl acetic acid. Now this is your phenyl ring. At the alpha position you have hydroxy group as well as acetic acid. Acetic acid is CH3COOH, isn't it? This is CH3COOH. Now to this, what happened? This hydrogen is replaced by your this particular hydrogen from here. One is shared with the benzene ring. That means CH3 becomes CH2. COH. What happened to the one hydrogen? One hydrogen is shared by one hydroxyl group. So now count 1, 2, 3. So this becomes 4. This is 3-hydroxy phenyl acetic acid. Now come back to aldehyde. Now I said, what is the sequence? First I need to introduce this COOH. Now whenever you see alpha hydroxy phenyl acetic acid, you have to remember alpha halo acids, which reaction which we are going to speak about, we are going to involve HVZ reaction in this. This is the concept, you have to remember this. HVZ reaction forms alpha halo acids, isn't it? Now in this HVZ or this particular benzaldehyde reaction, first try to do reduction process. Why am I telling this? I'll tell you. Reduction in the presence of reducing agent sodium borohydride. When you reduce, you will be adding one hydrogen to this, one hydrogen to this. So this becomes your CH2OH. Now what are we going to do? Gradually to this OH, right? Now I need to remove this OH and add one more carbon group. So what am I going to do? I am going to use a nucleophile, that is KCN. Then this OH is out and CN goes in. I am gradually trying to add or extend the chain. This becomes CH2CN. Now this CH2CN, see the chain almost, I have got two, isn't it? I can, from this cyano, I can further convert. Now I said we are going to use HVZ reaction, or let us do first H plus in the presence of acidic medium. Then what will happen to this? In the presence of H plus, cyano group is converted into acidic group, CH2COOH. This CH2COOH, now this becomes, you can use this HVZ reaction to prepare alpha halo acid. This alpha halo acid HVZ reaction, I am using PBr3. Now this bromine and your this hydrogen will be replaced, and what do I get? I am going to get hydrogen. Yeah, this hydrogen is here, and with one Br, this is over, and CH2OH. Still, what should I do? I need to take out this bromine, introduce KOH. Introduce OH. To this, I am going to introduce aqueous KOH. So in aqueous KOH, and alkaline KOH is different, aqueous KOH is different. Aqueous KOH when you introduce, you're going to take out that Br and add this OH. So once again, let us come back. I need to prepare this compound. I have these two combinations. I need to add this. From where did I get? First from reduction. Always reduction easy. Then after converting into alcohol, I took out this OH, KCN. After I got KCN, I need to introduce carboxylic group, H plus in presence of water. Done. Then to this I did HVZ reaction, PBr3. I got this. Now further in presence of aqueous KOH, I got this compound. Done, isn't it? Let's come back and see the next type of conversions. Next type of conversion, what are we doing? We are trying, suppose in the exam paper, if they ask you some of the combinations. So now benzaldehyde, these are the basic things which I thought I'll explain you all. Now we will come back and see some of the conversions of benzoic acid. Benzaldehyde, those are the maximum things they will ask you. You can learn from these reactions only how conversion of benzaldehyde to benzyl alcohol, conversion of benzaldehyde to benzoic acid, again conversion of this to this, then finally benzaldehyde to this compound. So different types of combinations are there in this reactions only. Now let's come back and see the next set of reactions where we are going to see benzoic acid conversions. So benzoic acid conversions. So in benzoic acid conversions, let's see. Most important, let us write the formula. Suppose in benzoic acid, I am going to take benzoic acid in the center. If they ask you to convert benzoic acid to, or if they ask you to convert different combination, it may be from here to the other compound, or they may ask you other compound to benzoic acid. Let's see the first one. Now if they are asking me to convert acetophenone to benzoic acid, what is acetophenone? Acetophenone, right? Acetophenone. Now what is this? You have a compound, that is benzene ring, COCH3 is acetophenone. Now I need to convert it to benzoic acid. So what are you finding? Already CO group is here. I need to take out the CH3 and try to convert it to an acid. What can I do? Acetophenone first. What do? I am gradually going to add, because I need to come back to this. I am going to add an oxidizing agent KMnO4 and KOH. Then what do we get? I get COOK. To this COOK, now this almost it is ready. I need to take out this potassium, so I'm going to introduce H3O plus. That's it. I've got first one. Suppose if they ask you to convert bromobenzene to benzoic acid. Bromobenzene to benzoic acid. Now what should I do? I am going to take bromine. What am I going to do? This is what I have to convert to this. What is this particular thing? As soon as you see bromine, try to add Grignard's reagent magnesium ether. When you add Grignard's reagent, you get MgBr. Okay. Now this MgBr. Now I'm almost close. I always said you to convert this into carboxylic acid, try to add carbon dioxide. Then what do I get? I am going to get COO MgBr. Now from here, if I do hydrolysis, H2OH plus, this comes out as MgOHBr and the leftover is hydrogen. It's basically like this, isn't it? MgBr plus HOH. Get hydrogen comes here to this as carboxylic acid. This comes out as MgOHBr. That's it. Simple. Let's come back and see one more. Now suppose if they ask me to convert one more type of conversions, we'll see bromobenzene is done, acetophenone is done. Now I'm going to ask you, or if they'll ask you to convert phenyl ether to benzoic acid. So what do? You're going to write first phenyl ether to phenyl ethene. So what is phenyl ethene? It's nothing but styrene. Styrene formula, benzene ring. This is H double bond. I need to convert from this to this. See here, first whenever you have a double bond, you easily can add hydrogen here. You can break this and add hydrogen. Let's add hydrogen. I can use platinum or palladium. One hydrogen here, one hydrogen here. CH2, CH3. Now I'm going to add oxygen to this with potassium permanganate, oxidizing agent. Then irrespective of the alkyl group, this gets oxidized and we get benzoic acid. Let's do one more now. This is done. Now phenyl ethene to styrene. That is also over simple, isn't it? I broke the double bond and I got. So remember, whenever you get a double bond like this, it's easy to add hydrogen using a reducing agent. Now let me convert, if they give you, convert ethyl benzene to benzoic acid. Ethyl benzene. What is the formula? Ethyl benzene, basically, here this thing, CH2, CH3. Now I'm trying to follow this step, this one. Right, ethyl benzene. So in the exam, if you study this is one type of conversion. In the second thing, this from to this is one more type of conversion. Now ethyl benzene, when I have to take KMnO4 and same thing, I'm just saying KOH. Now what do I get? I'm going to get your, irrespective of the ring, alkyl group, COOK. From COOK, we very well know once you get this. I have done here also. See here, same thing. If I'm introducing H3O plus, I get this compound. That's it. So we've learned 4 conversions. Let's come back and see different next type of conversions of benzoic acid. Let's come back and see benzoic acid conversions further. Now before going into the benzoic acid conversions, now till now what do? We have seen converting other elements into benzoic acid, right? I'm left with one more, which is very important. Then I'll come back to benzoic acid conversions. Now in the exam paper, if they give you to convert nitrobenzene to benzoic acid, this is what is given to you in the paper. Nitrobenzene to benzoic acid. Let me see. So for this, I'll give you a small trick how to remember. So basically, nitrobenzene they've given you, right? That is nothing but your benzene with NO2, isn't it? Done. What should I convert it to? I have to convert this into benzoic acid, that is benzene ring with COOH. So when you have this combination, remember, just remember this. Nitro and acid is here, isn't it? So N and acid, both are here. In between, the steps which will include is A, B, C. This is your step. Remember, nitrobenzene, aniline, nitrobenzene and acid. So this is acid, this is nitro group. So in between you're going to follow ABC steps. What are the ABC steps? Let's see. First, as soon as you get nitrobenzene, try to convert it into aniline, right? The first step, A stands for aniline. How can I convert it into aniline? Now I said here, this is NO2. By using reducing agents like hydrogen in the presence of palladium or SnHCl, I can convert. Now A is done. From A, you're going to convert it to B, that is BDC. What is BDC? C6H5 N2Cl is BDC. So how to convert aniline to BDC, we very well know. We've used this NaNO2 and HCl, converting aniline to BDC at how much temperature? 273 Kelvin to 278 Kelvin. This is also over. Now BDC. Now C. From BDC, what do you do? Now you are going to introduce to this, right, copper cyanide in the presence of KCN. Okay, I'm very less space, I'll do it here. So copper cyanide, then what happened? Nitrogen gas is out, copper chloride is out. What are you left with? Cyano. So you're getting CN group. To this CN group, now what do? You're going to do hydrolysis or H3O plus. In the presence of acidic medium, H3O plus, you'll be doing hydrolysis. That's it. So remember, whenever they give you nitro here and acid here, the steps to be followed are ABC. This is your sequence. Let's come back and see the next type of reactions here. Now what are we going to do? We are going to learn or study all the conversions of benzoic acid. Now what are the different conversions which you have for your prescribed syllabus? Let me write. So benzoic acid converting into, like if they ask you, they may ask you a combination of meta nitro benzyl alcohol. They may ask you this, meta nitro benzyl alcohol, or they may ask you to convert benzoic acid into aniline, or they may ask you to convert benzoic acid into benzaldehyde. Benzaldehyde. This is what they're going to ask you. Maximum number of combinations. Now let us start with the first one. What is the first one? I have to convert benzoic acid into meta nitro benzyl alcohol. This is what is given to us. Okay, don't get panic if you see this. Simple. Let us write the structure first. What is the structure? They've asked me benzoic acid. Let me write benzoic acid here. Then they've asked me meta nitro benzyl alcohol. So what actually is this? This is, you have, okay, or para, ortho, meta. At meta position you have nitro group. They said benzyl alcohol. So benzyl alcohol is something where you have OH group attached to CH2 group. Directly not, but to CH2 group. This is meta nitro benzyl alcohol. Now when you observe, here you have acid group, here you have alcoholic group. Simple, isn't it? First thing, what should you do? I can convert from acid to alcohol by removing this oxygen, adding hydrogen. That is nothing but reduction. Simple. Acid to alcohol, direct link. That is what we have studied. How can I do from alcohol on reduction converts it into acid? This is what we have studied. Okay, this step I can do. So what else should I add? Nitrogen, nitro group. So simple, isn't it? I can do a process called nitration to this. When I do nitration in the presence of nitrating mixture, that is concentrated HNO3 and concentrated H2SO4, what do I get? I'm going to add a nitro group, right? We already studied nitro is meta directing group. The maximum product is meta. So what do I get? I'm going to get your COH with NO2 in the meta position. Done. Now what did I say? I have to remove this oxygen. Okay, let me use one more color, then you will understand. I need to remove this oxygen from here and add hydrogen to this. What is this? Addition of hydrogen is nothing but reduction. I can use which agent? I can use a reducing agent, lithium aluminum hydride. Then automatically oxygen is lost and hydrogen is added. How many hydrogens? 2 hydrogens. That is your meta-nitro benzoic acid. So the first one is over. Meta-nitro benzyl alcohol. Simple, isn't it? See the group, what to add, and use the required reagents. Now let me see one more comment. They asked me to convert benzene to benzoic acid to aniline. So simple. Let us write the this one. What did they ask me? Okay, let me use a different page for this. So they've asked me to convert benzoic acid to aniline. They've asked me to do this in the exam paper. So simple, as soon as this is given, write the formula first. Now this is benzoic acid, COOH. Okay, I need to convert it into aniline. Nothing to panic, it's easy. Now what did I say? Whenever you have to convert or form this amine group, you need to add ammonia. So what do you what happens? Suppose if I add ammonia to this NH3, what will happen? The OH from here, right? Now this OH will be replaced by this hydrogen. Basically ammonia, you need to get this bond, right? This is the bond. So ammonia, how can you change? It can be H2 and H, right? This water, okay, I'll use a different sketch pen. This HOH and this comes out as water. Then this NH2 goes and adds here. Then this becomes CONH2, benzamide. Now simple, I'm only left with this. I should take out CONH2. So what am I going to do? I'm going to add to this like a simple bromine in the presence of NaOH. You would have seen preparation of the aryl amines or preparation of primary amines, right? Hoffman's bromide degradation method. This is Hoffman's bromide degradation method. When I add this comes out as NaBr, and that the whole thing, like this is out, and you're left with NaOH. This is Hoffman's bromide degradation. Simple, isn't it? Now let's see one more. Now what did I ask you? That means whenever you see amine, you need to add first ammonia to get that. Next reaction, suppose if they ask me to convert benzoic acid into to benzaldehyde, that is what I have written. Yes, benzoic acid to benzaldehyde. Then I have to see this. Let me see. Now write the formula. Aldehyde, right? This is COOH. Now I have to convert it to benzaldehyde. This is CHO. Done. Right. Now what is this? This is acid. This is aldehyde. Now again, this is Hoffman's bromide, I said. Now we'll use one more different type of name reaction. Now whenever you see benzaldehyde, you have to remember the name reaction which prepares benzaldehyde is Rosenmund reduction. Yes, I can prepare benzaldehyde using Rosenmund specific characteristics. If you're trying to prepare here Hoffman's bromide, but here Rosenmund reduction is used to prepare benzaldehydes. So I can use that Rosenmund reduction. Okay, Rosenmund reduction. So what is Rosenmund reduction? In the presence of palladium and barium sulfate. Okay, from where is this prepared? Or this is we are getting Rosenmund reduction basically tries to use acyl chlorides, isn't it? Or this is your group COCl, right? Done. Benzoyl chlorides. So this benzoyl chloride in the presence of reduction, you will get that in the presence of palladium barium sulfate as a reducing agent, it will get converted to benzaldehyde. But how did I get this? That means we are going back again to our first chapter where we are using thionyl chloride. I can comfortably introduce thionyl chloride SOCl2 to this. So SO2, I said it comes out as SO2 sulfur dioxide gas, and I also said HCl also would be out, and the leftover Cl, SO2 is out from here, HCl is out, and one Cl goes and joins here. That's it, isn't it? So benzaldehyde, if you see Rosenmund reduction uses benzoyl chloride. Benzoyl chloride, I got it from thionyl chloride, isn't it? So that is how you're going to like convert it, and these are the maximum conversions of benzoic acid which you have. Now suppose if I have to go to the next type of conversion, what did they ask me? I have already given you in the index. If they ask you to convert, what is that? Now we'll see. We will write the question first. We have to learn, if they ask me, convert benzyl alcohol or benzyl chloride, we will do benzyl chloride. This is the thing. There are two possibilities. They may ask you to convert benzyl chloride to 2-phenyl ethanamine. They may also ask you benzyl chloride to benzyl alcohol. This is what is the combination 2, right? We will see both the combinations how to do. Let me change the page now. So I have to convert benzyl chloride, isn't it? Now what is the formula for benzyl chloride when I have to convert? So let us write what to do first. First, in the exam paper, if they ask me to convert benzyl chloride to 2-phenyl ethanamine, correct? Let us write the formula. Benzyl chloride is what? This is basically benzene ring with CH2Cl. This is benzyl chloride. They said 2-phenyl ethanamine. So what should I do? I have to take the benzene ring. Now they said 2-phenyl ethanamine. Eth, 2 carbons. Ethanamine is 2 carbons, 1 and 2. Amine is there already, NH2. So filling the hydrogens 1, 2, 3, 4, 1, 2. This is 2. This is 2-phenyl, second carbon, 2-phenyl ethanamine. This is over. Now when I have to see, like see here. Now when I see this compound and this compound, this CH2 is already there. One CH2 is already there. I need to introduce this CH2 and H2. Isn't it? Now where will I get this CH2 and H2? Let me see. If I close this hydrogen here, if I close this hydrogen here, you are left with only cyano group, isn't it? Just see carefully. This is cyano group. So I can get this compound from cyanobenzene, or if I have to say C6H5 CH2CN, because C6H5 CH2CN. Let us come back and write that. I can get this product from this. See here, benzene ring. This CH2 is here and cyano, correct? Now what did I do? I need to add hydrogen to this. When I add hydrogen, how many hydrogens? 2 plus 2, 4 hydrogens, which will add this reducing agent. What is the reducing agent? Lithium aluminum hydride. I also did one video compared to lithium aluminum hydride and sodium borehydride, which is better. So I picked up lithium aluminum hydride. Done. I have already given this reason. Now from here till here, you need to introduce, you need to take out this chlorine, you need to introduce cyano. Simple, isn't it? I can add your Kc into this. When I add Kc into this, what do we get? I get KCl. How did I do? I took out this KCl from this and I introduced Cn. I got this. To this Cn, as I showed you, 2 hydrogens here and 2 hydrogens here. Done. Benzyl chloride to 2-phenyl ethanamine. Now let us write one more. Suppose if they ask me to convert benzyl chloride to benzyl alcohol. So simple. They are relating haloarenes chapter and alcohol chapter, benzyl alcohol. I need to do this. Let's see. First let us write the formula. Benzyl chloride, CH2Cl, benzyl chloride. Now I have to convert this into benzyl alcohol, CH2OH. Now what is the difference? Ring is the same, CH2 is the same, Cl and OH both are different now. Yes, so now what should you do? You need to introduce that or you need to take out that Cl from there. Yeah, I can take out that Cl and make it into oxide, phenoxide ion, and then come back to alcohol. So to take out or to remove this Cl, I think I can introduce NaOH. When I introduce NaOH, what will happen? I am going to take out NaCl first, minus NaCl. Now gradually what did you get? You got OH directly. But here suppose in the exam paper, if they ask you to convert the same in 2 steps, right? If they give you write in 2 steps, done. I here directly if I take out that OH goes and done. But suppose as I said 2 steps, what should you do? I'll tell you. So now see here, take benzyl chloride. 2 steps. First step is this is a given thing. Now you're going to introduce NaOH. Now what will happen? It's going to form a stable compound. This Cl and this H comes out. I'm doing it in 2 steps now. This is 2 steps. So in step 1, this is your step 1. What is that? This is O, CH2O, Na. This is step 1. Now to the second step, what am I going to do? Because they asked me in 2 steps, this I'm going to use the acidic medium. This comes out and this goes and forms CH2OH. That means that basically if you take the acidic medium, if I take HCl here, NaCl comes out and H plus goes in. So benzene alcohol. This is 2-step process. This is 1-step process. So let us come back and see different set of reactions now. So I have successfully completed all the aromatic conversions. We did conversions, let us recollect once. Conversions of benzene to different forms, conversions of benzaldehyde to different, then conversions of benzoic acid. Then we've also seen conversions of ethyl benzene, all these into benzoic acid in that way. So all the possible combinations that I did, you'll be getting from those only different types. Now let us start with aliphatic conversion. Aliphatic conversions, you need to be a little bit tricky. It is easy. I'll be using Markovnikov's rule more frequently. I'll show you. I'll be adding nitration. Okay, I'll show you all those. Let us start first with aliphatic conversions. The first type of conversion, very famous and very important, is what? Let us read what we are going to study so that you will not forget. In aliphatic conversions, right, first important thing which I'm going to teach you is conversion of propanone to propene. This is one. And conversion of propene to propan 2 all. One small letters on alphabet, right? Second, conversion of propene to propan, 1 all. This is famous one. Next important thing, conversion of ethyl magnesium chloride. Ethyl magnesium chloride to propan, 1 all. Or one more combination, conversion of methyl magnesium bromide to 2-methyl propan or propan to all. Okay, so many combination. Let us see this first set first, then come back. Now first one, let's see, what did they ask me, or what did they give me to find out? They've asked me to find out propanone to propene, this step, because this is all one set to be studied. Now you'll be doing 1 conversion, 2 conversions, 3 conversions, 4 conversions, 5 conversions at a stretch. Now when I have to learn the first one, propanone to propene, let us write the heading. Propanone to propene, correct? Now propanone to propene, when I have to see, let us write the formula. Formula is what? CH3 prop, no? COCH3. This is propanone. Now what should I convert this into? I need to convert it into propene, isn't it? So let us write a bit easy, only concentrate. So propane is 3 carbon chain, 1 2 3 double bond, CH2, 1 2 3 H. This is CH2. This is propene. Done. Now first important thing, this is propanone, already 3 carbons are there. What is my task? I need to take out this oxygen. So removal of oxygen is what? It is basically reduction. How many should I add? I need to add first on reduction first, let us see, because 1 hydrogen to this, 1 hydrogen to this, I'll be adding 2 hydrogens to this reduction. What do I get? CH3, 1 hydrogen to carbon, 1 more hydrogen to oxygen, that is secondary alcohol. So this will become secondary alcohol. Now still I am not done. To this secondary alcohol, I need to dehydrate. Then when I dehydrate, remove water molecule, there is a shift of double bond here. So now what will happen? I am going to perform dehydration reaction. Dehydration, that is dehydrating agent, H3PO4, phosphoric acid, or Al2O3, alumina, you can use that. So when you take out water, from where will that water will be lost? OH from here, H from here. Okay, let me write the H from here. Both will be lost as water. What do you get? There's a shift of bond here. So this becomes propene, isn't it? Simple. Now let's come back. The first one is over. Let's come back and see the next one. What is this now? Okay, here only I'll write. Right. Propene to propan to all, they said. Now propene is this one. So propene is this one. Now propan to all. So what is propan to all formula? Propan, let me write that. Propan to all, right? 1 2 3 prop. This is 1 carbon, this is second carbon, oxygen. So propan to all, CH3, this is H, this is CH3. Okay, now 1 2 3 4, right? Now they said propan to all, I need to write. Now tell me, how can I do this? I need to add OH, means I need to break this double bond. To break this double bond and add water, hydration, what should I do? First of all, I need to add water, H and OH. Correct? Because I need to break this. When I have to break this, 1 H adds to this, because already there's H. This becomes CH2OH. That means it is basically CH3, CH2, CH3. But here 1 hydrogen is replaced by OH. That is what is the thing. So this hydrogen is already there. Done. The bond is broken. And that one after the bond is broken, that OH comes and adds here. So is it not propan to all? Let me count. 3 plus 1, 4. For this carbon, 1, 2, 3, 4 oxygen, and this is this one. Now let me come back and see one more. So this is over. Let us tick this also. Second, third combination. Now what did they ask me? They asked me to convert propene to propan 1 all. 2 all is over. Now propene to propan 1 all. This is what is here. Now let us see. Now propene 1 2 3. So propene, this is CH2, this is H, 1 2 3, and this is 2. I need to convert this into propan 1 all. 1 2 3. So here this is your OH bond. So that is your alcohol. This is CH2, 1, 2, 3, CH2. This is propanol. Now what should I do? When I have to see this, I need to break double bond. Then only I can add this OH. But here, where is the OH? Here the OH is the terminal carbon. Now simple, isn't it? I can introduce this OH either using peroxide, anti-Markovnikov's rule. Okay, let me see. Anti-Markovnikov's rule, we use it for alkenes, isn't it? Yeah. So anti-Markovnikov's rule. Okay, I've used the sketch pen. Now HBr and introduce in the presence of peroxide. Now what will happen? The negative addendum goes and adds to the carbon having more number of hydrogens around the double bond. So this Br goes and adds here. This H comes and adds here. What am I going to get? I'm going to get CH2, this is CH2, this is CH2Br. Okay, now this is bromine, negative, OH is negative. What can I add? I can simply to this add aqueous KOH. When I add aqueous KOH and heat it, KBr comes out, and what do I get? OH goes and adds to this. That's it. This is propanol. This is one type of conversion. So I think using the first one, I have converted propanone to propene, propene to propanol, propene to propanol. Over. Now I have two sets now. What did they give me? They have given me two combinations. Let us divide this page into two. Here they have given me to convert. According to the question says it is ethyl chloride to propanol. This is the question which I have copied. Done. Let me underline. Next question is this is methyl magnesium bromide. Methyl magnesium bromide to propan. Here it is 1-ol, here it is 2-ol. Let me underline this also. So now they've asked me ethyl chloride to propan-1-ol. Let us write the formula. Ethyl chloride is what? It is C2H5. This is ethyl chloride, no, ethyl magnesium chloride. I'm sorry, here ethyl magnesium chloride. Okay, here magnesium bromide, methyl. Here it is ethyl magnesium chloride. C2H5 MgCl. What should I convert it into? I need to convert it into propan-1-ol. This is your propan-1-ol. This is CH3, CH2H2. Okay. Now see here, this is Grignard's reagent. To this Grignard's reagent, it can undergo addition reaction, isn't it? Now how many are there? Here there are already two carbons. Here how many are there? 1, 2, 3. Means I need to add one chain completely to this, right? Means I need to get one carbon atom attached to this. Then I can further go for hydrolysis. Now one carbon atom which will have methanol or formaldehyde, isn't it? Only one carbon atom, formaldehyde. Yes. So this is methanol or formaldehyde. Now what will happen when you add to Grignard's reagent? As soon as you see Grignard's, try to count the number of carbons here and add the number of carbons to this. What do you get? You get C2H5. Now this C2H5, CH2O MgCl. Whole thing will add. Now to this, what do? I'm going to do hydrolysis, H2O and H plus. Then what will happen? C2H5, this C2H5 written together is this, like this. CH2 is here. Now magnesium chloride will come, this will break up into, this is like HOH, isn't it? What do you get? MgOHCl. MgOHCl, this is over, and H comes in, adds here. Right, so this is your compound. Already oxygen is here, that oxygen, and H from here comes and adds to this H, and OH goes and adds to this. This is your conversion. Now they've asked me to convert methyl magnesium bromide to propan-2-ol. Let us write the formula. Methyl magnesium bromide CH3 MgBr. What should I convert into? Propan-2-ol. 1, 2, 3. To the second carbon you have OH. Propan-2-ol, CH3 H and 3. This is propanol. Okay, but what did they ask me? Propan-2-ol, they said. Let us see how can I do this. Now basically when I have to come back to this compound, how many carbons are here? There is only one carbon atom. Here how many are there? 1, 2, 3 are there. Okay, that means I need to take or pick up this 2 carbon chain and add to this. Then only I'll get 3. Now let us add. What can I add? I can add CH3, C double bond O, CH3. Yes. Now, when I add this total carbon or this particular compound, what do I get? I'm going to add the whole thing to this. Let me see whether I'm doing it correctly or not. CH3 is here. This carbon is in the center. This methyl group is here. This CH3 is here. To this O, MgBr adds OMgBr. Now what am I going to do? I'm going to further hydrolyze this H2O. What will this H2O become? AH and OH. Then there is a cleavage of the bond here. This H plus and OH minus. This H comes and joins here. What do I get? Get MgOH-Br. And what is left now? 1, 2, 3. Okay, 1, 2, 3. 1. Okay, if I have to see H3, isn't it? Okay, this H is here. MgOH-Br, and there is one more methyl group here to this compound. This becomes CH3. So what should I write this compound as? Now it should be 2-methyl. Okay, if I have to see this is your prop main carbon. So this has to become 2-methyl propan 2-ol. So this is 2-methyl propan 2-ol. Question only, I took it wrong then. It is 2-methyl propan 2-ol. 2-methyl propan 2-ol. This is the combination. This one. That means earlier the product, in the product 1, 2, 3, 4 are there. Here there was only 1. So I took 3 carbons here. This is propanone. Done. Let's come back and see the next set of reactions.